All right, let's go ahead and get started. Before I do, anybody have any questions about anything about just how fast last time? All right, one thing I know I forgot to mention last time, well, obviously a lot of you want to see it, but I put a survey online, this quiz 0 under the quizzes heading. Thank you to those of you who already saw it and responded to it. But that'll be up there. I'm going to change the due date because I forgot to mention it, but it should only take you a few minutes. I'm just trying to get a sense of where everyone's coming from before we get too deep into things here. So if you haven't already looked at that, please take a look at that over the next couple of days. And if you've already responded to it, if you want to see my response, you can go back and revisit it. Also, since I couldn't show it last time, I wanted to make sure everyone knew where this page was. So on our Canvas, under this modules tab, the things that you'll see me update pretty much, on approximately, every class period. Under this class notes unmarked, this is where I put all the slides, basically all the new slides that I make. And then these class notes marked, this is basically, it's got those 3 photos that I took of the board on Monday. And basically I'll be putting our, any annotations I make to the slides in there on a daily basis. And starting with today, I'll put the recording of today's class in here as well. But yeah, I just wanted to make sure that everybody knew how to find this thing. All right, let's get back into it. So, and I'm hoping this is the only day I will have to do this, but could I ask somebody on that side of the room to take pictures of a slide before I move on to each one? That way I have something to post at the end of the day. So if someone could take pictures and send an email to me. Okay, so I got at least one volunteer. Thank you so much for that. So the drawing tab that I usually use is not working. So I'll have to do it. All right, so we did this example here of this limit here. But now let's look at this one. So it's not showing it. All right. So let's look at this new one here. I want to find the limit. And did I go over this notation last time? This expression, this function here, as an x approaches -4. So it's really close to -4. So we did a lot. With the last function we looked at, we had that table value around. And found the limit, right? Is that going to be available to us here? This is next year. Right, so if I call this that one -4 is 5. That's not something we rely on. But we still use that, kind of table for this is not we have some. But just based on those, we have kind of we have the first of all, so I do this should be negative 8.001 and does that kind of confirm your suspicion of what the limit might be? So that is the case. That's a this function and here's kind of what I'm limited. So as I said last time, I think we're all used to the idea of, trying to figure out what value a function has at a certain place. Limits are not. I don't want to know what the function value at a certain location. Limits are after, what value is a function nearing as the input value. So in this case, I can make f of x belongs to negative 8. I can get this function. So we know this function get greater equal to negative 8. Are we okay? Do that. So let's go back to that. Is negative 4 in the domain of this function? It's not. But all the numbers around negative 4 are. So because of that, I And the reason I'm not going to run into problems is because so in this one here, I was looking at the limit of the function's x approaches 2x. So this is all no, all including 2. So this is for as x gets closer and closer to 2, I think this is the limit of this function everything that I equal. So, and that's a key distinction. So if I say the limit of a function is something, I'm not necessarily solving, but the function they're independent from each other. It's a really good question. Anything else to talk about with this one before I ask for a photograph and move on? All right. So let's talk about the formal definition of a limit. So if I have a function f, there's the final axis. We're really concerning ourselves with what's happening in this little tiny area around the number. So like in our last example, I want to know the limit was x approach to before. I'm not looking at value, for example. I'm only looking at things near that a, which you'll sometimes hear me call a base point. As x approaches a, let f of x approach L. So as x gets really, really close to a, f of x gets really, really close to this number, or this value of capital L. Then L is the limit. So as x approaches a, f of x approaches this limit. And just to refresh the notation that we've been using, and you'll see this a lot. Not just the the limit, the function might be defined at that point. One of those might not be true. You know, the function had that point wasn't actually. Any questions here about any of the ideas, notation, anything like that? So let's look at a related function here. So this is a so obviously you can't put a negative 4 into this, right? But the next equal negative 4 wants to stabilize it. Basically what that top function looks like, I minus x plus 4. It's going to look like a straight line almost like x equals negative 4 is 10. So right here, you're going to have a hole broken here, and you have this one here. So now we have a function that's defined for all values of x. This is very close to Yeah. So this one negative 4, negative 8. So based on the definition we're talking about, what kind of things you got? What do you think? Let me ask that question. More general way. Do I care about what the function value at? Do I care about this here? Or do I care about here? Right. So if I put the word approaching, what do you think it is? Yeah. So, and this is probably not around. This is the this comes against everything you can. Instead of looking at, yes, there's pointers here, but like based on the definition of what we're just having over, this doesn't really I only care about these points. The ones that are in the vicinity of that. And in the vicinity of that this combination here is whole, you're approaching why these moving bits. You'll never get there. Yeah, this line is part of the so this is one of those cases where the limit of that the function is defined. They disagree. Any questions there? Okay. Go ahead. Did you repeat the single part again? Yeah. So, I think this is what you're getting out of the So, two different ideas here. The limit of the function at this point, the value of the function at x equals negative 4. So the limit is all about what happens when x gets close to negative 4. The value of the function. What is y equal to when x is negative 4? So approaching exactly the exact equation. And those two things. We're not going to do. That's a great. All right. Right. And x is proof. This proof. All right. So again, let's try the most. Maybe the most work. Can you define that? F0. So figure out what else can we try? That's going to be really hard. But I'll set up the effort. I got a little more time. Let's do the same thing here. So we approach Maybe we can do this if you're all on the same page. Yeah. All right, so we have these pictures going. I'm not willing to believe it. Let's go ask somebody else. I think the graph will make this point for me better anyway. What was the cosine of what? Pi over 2x? Okay. So what are the ones I asked for? F of 0.1? You know what? I think it's rounding. And it's doing it in a way that makes it hard to figure out. Okay, yeah, it is. But, so we're getting a limit, based on the calculation we just took, we're getting a limit around 1, right? So that means if I zoom really far into this, we should see that around the y-axis, it's getting closer and closer to 1, right? So let's do that. Okay, I'm zoomed in pretty deep here. And it's really lagging on me now. It's not zooming in anymore. So let me talk about why that is. I hate the rounding. Go back to that slide. Actually, maybe I should zoom out on this a little, zoom back out so I can talk to this in here. I could have, yes, but luckily the home button works too. So as we get closer and closer to, around the y-axis, goes up and down on a regular way. But you use the cosine of pi over 2x. The closer I get to 0, the more we're okay with that. That's kind of the bigger what's going on, the closer we get to 0, the more rapidly it's just going to bounce up and down. It's never going to get more rapid. Because of that, their value. So Doesn't exist. Which, yeah, I have not seen that happen with my calculator before. For the clear graph. All right. Can I get a photo of that or no? Right here does not exist. Right. Before there, so there's no as x gets closer and closer to 0, the function just oscillates between -1 and 1. All right. Now, what is this function? So what's the basic thing you want to look at her? Yeah, it's really domain. So can't help you there, but is there anything else that's not in other words? So I think that gives a good idea. One very close from below. At least start there. So, 2010. That's also 1.999. So 100 times. So having said that, yes, no. Infinity. So when we say the limit of a function, there is no limit. That's the limit will exist. But being a little so we said the limit didn't exist in the last one, right? When we say the limit is infinity, and it is. Like I'll just do one more point here just to kind of drive that point home. That you're gonna get 100 million. So basically what is happening is this, as x gets closer and closer and closer to no balance. All right. Or is it not? Basically, you have this. Basically, Basically, you can give me the largest number you can think of, and I can find you an X value. So here's kind of the thing there. Are we saying limit exists? No. So technically no. Infinity is not a number. But basically all I'm saying there is there is no maximum. This function can be made as far as any questions there? All right. Has anyone seen, actually, did I get a photo of the last one before I, yes? No, that's not your bad, it's mine. Cool, all right. Now, I think most of you are engineering majors. Basically, the way this function works is this. If that input variable t is negative, the value if the value t is non-negative, then it takes the value. This one. Basically, one time equals 0. So, what is the limit of this function? Right? Yeah. So that's why I have closed that. So across the y-axis that. What do we want to do? I don't think I'll go and warn you now. There are many times I'm going to ask you questions that I'm kind of setting it up. What's the penalty for being wrong in class? No. So, I said, it does not exist. So let's think about it. That's all here. So if I get a picture of that. I'm going to throw another couple of definitions at you before we can answer this question for good. So one-sided limits. Ooh. So basically, we've talked to everything I'm talking about so far. I'm just speaking somewhere, which implies that I'm looking as x approaches some value from both sides. But we can break those apart and talk about the idea of one side of them. So if you see this little superscript here on the negative side, that means I'm approaching the x value of a. But I only want to consider x value as small. is usually set as approaching it from the left. The bottom line is this. The only little bit higher. So, corresponding to the left-hand limit. The right-hand limit is a very similar thing. Literally just copied and pasted this and changed the words that need to be changed. You're looking at, same page forward, okay? But you're only looking at so right. And the page line we have a hard here. That superscript is now inside the whole larger than that. Are we doing those distinctions now? That's or so instead of just talking about limit now, we have the idea of two-sided limit. Single-sided limit. Now that we have those, let's talk about this. Oh, sorry, one more note for you. The two-sided limit of a function only exists with both degree. And one thing that is important here, good question by Clark reminded that the function has at most one limit. So it will either be some number or it cannot be several. Either have a limit or but it cannot have a limit. So having that, let's go back and look at this Heaviside function. Can we talk about this? There we go. First of all, what that top thing? What is that? The first thing. We agree with that. So, all these two, all these. What's the next one? One. So now that what is that? Both the one-sided limits exist. So what has to be true about these for this to exist? Now, one more thing I'll ask you is this. What is do any of these limits have anything to do with this? What do you think about that? It shows up in other fields too. All right, so let's put a lot of these things together. So I've got a function here. What's the function approaching is that? All right, this one. We'll talk about why it's bad rather than one. Yeah, as you approach from the left, you move to two. What about the right? Fine. Also, so that is mine. One. Which is I think why. Any questions here? Those who thought the limit of this function was one. You want with that? Any other questions? I want to talk about this. Nah. All right, so that is all for section 1.3. As I said yesterday, I am probably going to give like something like 2 days after we cover something in here for the web work to be due. So I'm probably going to set that due date for the 14th, Friday night. Clark, question? Was there? I'm sorry. Did someone get a picture of the last slide? Okay, thank you. Yeah, thank you for doing that. All right, so we got a few minutes. Let's go ahead and jump into section 1.4 for a bit. All right, so we did some calculated limits in our last section. We'll do some more methodical. Before we do that, let's kind of, before I formally show you how some of these things work, let's talk about this. So I'm telling you that some function of perfect. I actually bumped this down a couple of bullets. You can see what I'm doing. So I'm telling you their limits at this are where you need. Is F and G to make these limits. So the F and G have these limits. What if I make a new Something called F minus. What do you think that would? And all of them with those functions. And the difference of them. I'll tell you that. When I have something 500. All I'm doing with this function is taking all of its values and so I'm going to go ahead and sign right now. Those are all true. So that's very much showing that your intuition is today. I'm trying to your intuition is going to kind of get into, but we'll explain why those things are. Any questions on either of those three so far? So let's generalize these things. So rather than just giving you specific numbers, I'll say this: the limit as x approaches a of f of x is L. The limit at the same point of that function g is m. So sum and difference and constant multiple. I think there's one more here. Nope. So based on those limits, generalize that the sum and difference of basically over the limit of this function f of x plus. Yeah, function. You just need to be times. So I mean, all you're doing with this stuff right here, you know, I'm just taking all of my multiplying by that constant. So because of that, any questions on those first two? All right, I'm going to stop there at 319. So, the slides and the photos and whatever I have. And the Zoom recording, keep an eye out for the first web work assignment. If you haven't already looked at it online, you can see it. If you can't, please tell me as soon as you can. I'll try to get that figured out for you. Is everyone here not to start? Okay, so it's available. All right. Otherwise, I'll see y'all Friday.